Hello students. So today I am doing class 12 science. So the topic is determinant. That is, we are continuing the same topic today also, that is determinant, right? So in the last class also we were doing the same topic, that is determinant. So today we will do questions from higher secondary question papers, that is of West Bengal Council of Higher Secondary Education, right? So now this question is from Higher Secondary 2016, right? And each question carries 4 marks, right? So, 2B number 2. If P, Q, R are not in geometric progression. I think you know the meaning of geometric progression. You did in class 11. There is a chapter, geometric progression. So, you should know the meaning of geometric progression in this case, okay? And this determinant is given. That is, what is the determinant given? 1 Q by P alpha plus Q by P. That is the first row. What is the second row? 1 R by Q alpha plus R by Q. And what is the third row? What is the first element? P alpha plus Q. Q alpha plus R is the second element and 0 is the third element in this case. That determinant is equal to 0. Now you have to prove that. So there is a relation to be proved. What is that relation? P alpha square plus 2Q alpha plus R is equal to 0. Okay. Now in this case, first of all, you should know the meaning of geometric progression. What is geometric progression? So I already told you that it is already done in class 11. Right? So what is geometric progression? So I am again explaining you what is geometric progression, right? Suppose there is a series. Progression means it is a series, right? So 1, 2, 4, 8, 16, then dot dot dot. Okay? So this is a series, like this is a series, right? So like 1, 2, 4, 8, 16, then comes 32, then 64. It is doubled. It is doubled of the previous number, that is 32, 64 and so on, right? So what is the first term here? That is 1. What is the second term here? 2. What is the ratio between the second term and the first term? It is 2 by 1, which is equal to 2. Again, what is the ratio between the third term and the second term? That is 4 by 2, which is equal to 2. Again, what is third term? What is fourth term divided by third term? 8 by 4 is equal to 2. Similarly, what is fifth term divided by fourth term? 16 by 8 is also 2. That is, the ratio between the succeeding and the preceding term is the same throughout the series in this case. So, this type of series is known as geometric progression, right? So, what is the definition of geometric progression? A series of quantities are said to be in geometric progression if the ratio between the succeeding and the preceding term is the same throughout the series, and that series is known as what? Geometric progression. But in the question it is given that this P, Q, R are not in geometric progression. These three terms P, Q, R are not in geometric progression. बुझ्दैछ? तो यो PQR चाहिँ ज्योमेट्रिक प्रोग्रेसनमा छैन. यदि PQR ज्योमेट्रिक प्रोग्रेसनमा हो भने हामी के लेख्न सक्छौं? So what will we write? If A, B, C are in GP, if A, B, C are in GP, then you can write down that their ratio between the succeeding and the preceding term is the same throughout the series, and that ratio is known as the common ratio. So in this case, what is the ratio between the second term and the first term? That is B by A should be equal to ratio between the third term and the second term, that is C by B. So if A, B, C are in GP, then second term divided by first term is equal to third term divided by second term. You can write down this relation, right? But in this case, they are not in GP. Suppose A, B, C are not in GP, that means the ratio between the second term and the first term is not equal to ratio between the third term and the second term. Is that right? If they are not in GP, then you can write here B by A not equal to C by B. Is it clear to all of you? So this is your geometric progression. Okay. Now let's do the solution here. So first of all, you write down the given part. Which is the given part here? P, Q, R are not in geometric progression. So let's do the solution from here. Since P, Q, R are not in GP, so this geometric progression is abbreviated as GP, right? They are not in GP. Are not in GP. So what can you write? Second term divided by first term not equal to third term divided by second term, right? So you can cross multiply it. Q square not equal to PR, or you can write Q square minus PR not equal to 0. Is that clear? So we have got this condition from given, that is Q square minus PR not equal to 0. Is it clear now? So we can copy this one. Now we will start from this given. This is the given part, isn't it? So from given you have to prove that P alpha square plus 2Q alpha plus R is equal to 0. So this is the given part, isn't it? So let us write down this given part first. So let us write down this given. So given here is, so let us write down this given, that is this third order determinant is equal to 0. Now you have to simplify this left hand side determinant. Okay, so how can you simplify it? Now in the first row, in the second term there is a fraction Q by P, there is also R by Q, there is also R by Q. Let us change this fraction into integer, like integer. Okay, so we can cancel this P, by multiplying this term by P and this term by P. Okay, we can cancel this P and P by multiplying it by P. So 1 should also be multiplied by P. So in the first row you have to multiply all the elements by P. So in the second row also you have to eliminate this fraction. In the fraction there is Q in the denominator, you have to eliminate this Q. So you have to multiply each and every term of the second term by Q. But we are multiplying ourselves, isn't it? So what will you write here is, so we are multiplying the first row by P, it should be cancelled, so write down 1 by P. Okay, and this second row is also multiplied by Q to eliminate this Q, isn't it? So it should be cancelled. So what will you write? What will you write before determinant? We have to write 1 by Q, isn't it? Okay, so now multiply all the elements of the first row by P. So what do you get? P1s are P, already 1 by P is written here. This P and P will be cancelled, isn't it? And you will get the same expression in the first row. Now this is also multiplied by P, P gets cancelled, we get only Q. This is also multiplied by P, so P into alpha, P alpha plus P into Q by P, P gets cancelled, we will get Q only. Is it clear to all of you? Okay. So next one, this all the elements of the second row is multiplied by Q here. In order to cancel that Q, already we have written 1 by Q here. So multiply all the elements of the second row by Q. So Q1s are Q into R by Q, Q gets cancelled. You write R. Now multiply by Q here, Q into alpha, Q alpha plus Q into R by Q, Q gets cancelled, you will get R here. So this is the second row. Now third row remains same now. This is P alpha plus Q, this is Q alpha plus R, and this one is 0, which is equal to 0. Is it clear? So now, what will you do in the next step? You cannot expand it now. Let us simplify this determinant with the help of property number 5. So now, this is P alpha plus Q, isn't it? So this is your P, only P is there. If you multiply it by alpha, if you multiply all the elements of the first row by alpha, what do we get here? P alpha. Okay. Now this is P alpha, right? So if you do R3 dash, that is R3 dash is equal to R3 minus alpha into R1 minus this row 2. So if P alpha plus Q minus P alpha minus Q is there, then you can cancel P alpha and Q will get here 0. Is that understood? Okay, look at the blackboard. If this first row is multiplied by alpha, okay, then R2 as it is, keep it same. But if the summation of these two is subtracted from this third row, P alpha plus Q, you will get it as 0. Is it clear now? So let's use this property. Okay. So now, so what is R3 dash here? R3 dash is equal to, let us write down R3 dash. That is the new third row. We are using property number 5. So R3 minus alpha into R1, because this P is multiplied by alpha. So alpha into R1, right? Then minus Q. Q is there, only Q should be here also. So minus R2. Is that clear to all of you? So that we can have here P alpha plus Q instead of P alpha plus Q. After using this property, you will get 0 here. Okay. So in this case also you will get 0 in that case, because Q alpha plus R, it is already multiplied by alpha. Q alpha, it is multiplied by 1. That means minus R2 is there. This one is also 0, because Q alpha plus R minus Q alpha minus R. Q alpha R gets cancels here. So this one is also 0. So in the new third row, you will get two elements as 0. And this third element 0 will be changed automatically. Okay. So now let's use this property now. So is equal to 0, right? So or if you cross multiply by PQ into 0, you will get 0, isn't it? And in this case, P is not equal to 0 and Q is not equal to 0 in this case. Okay. So if you cross multiply 0 by PQ, you will get 0 here. So no need of writing this 1 by PQ, because PQ not equal to 0. Okay. If PQ is equal to 0, 1 by 0 will be undefined. That's why PQ not equal to 0. Right. So you don't have to write this 1 by PQ out here. So or. So now what do we get? Now only third row will be changed. First row, second row remains same. Right now, first row is P, this is Q, and P alpha plus Q. First row remains same. Row 2 also remains same. That is Q alpha plus R, Q alpha plus R. Now, how can you change this row 3? That is R3 minus alpha R1 minus R2. Okay. What is R3 here? P alpha plus Q. Let us write here P alpha plus Q. Then comes what? Minus alpha into R1. That is minus R1 is this first term of R1. Right? Minus alpha into R1. That is minus alpha P. Minus alpha P. Right? Then minus R2 is there. Minus R2 means minus Q. Here you should write minus Q. So, now it is QR. It is P alpha plus Q and Q alpha plus R. Q alpha. So now, what will be the second element of the new third row? Now, R3 dash. Now this will be changed. So R3, Q alpha plus R, Q alpha plus R, right? Then minus alpha into R1. What do you mean by minus alpha into R1? This one, minus Q alpha, right? So let us write here, minus Q alpha. Then minus R2, minus R. That is minus R. Is it clear? Next, this one will be changed. Now what will be the new third element of the new third row, right? So let us write down this one. So R3 dash is equal to, what is R3 here now? 0. 0 minus, right? Alpha into R1 means this one. Alpha into P alpha plus Q, right? This is 0 minus alpha into P alpha plus Q. That is alpha into P alpha plus Q, right? Then minus R2. What is minus R2 here? Minus Q alpha minus R. Minus sign change. Because of that minus sign, here the sign changes. That is minus Q alpha minus into plus minus. There is minus into plus is minus R. Here you should write minus R. So this is the new third row. Is that clear now? So you should write is equal to 0 also. Is equal to 0 because this is an equation given in the question. So you have to write is equal to 0. This is given part. Okay. So you should write this determinant is equal to 0. So or now what is the first column here? P, Q. Now all this will be cancelled. This will be your 0. Right? What is the second column? Q, R. Q alpha, R gets cancelled. This is also 0. Now what is the third column? P alpha plus Q, Q alpha plus R. And now what is the third column? You can simplify it. So let us simplify it. You don't have to write that 0. That is the first term. Now multiply by minus alpha minus P alpha squared. Right? So minus into plus minus Q alpha, then minus Q alpha, then minus R, which is equal to 0. Is that clear? So we got this determinant, right? So now let us simplify it once again. Simplify also LI. Now let us expand it. So let us expand it with respect to the third row because there are two elements 0. So or let us expand it with respect to the third row. Now what is the method? Plus minus plus minus plus minus plus minus plus, right? So first of all you should write plus 0. But will you write 0? No, because 0 into any number is always 0. Then comes minus 0. Here also you don't write because 0 into any number is always 0. So you don't have to write it. But you have to write this term. That is plus. Plus. So within bracket, what is the term there? Minus P alpha square. Minus Q alpha. Minus 2Q alpha. Then what? Minus R. Bracket closed. If you consider this element, you have to delete the row and the column through the element. This one. That is third row and third column are deleted. What remain? P, Q, Q, R. Now you have to cross multiply P by R. What do we get? It is PR. Right? This is PR. Then minus. You should write minus sign in between these two terms. And Q into Q is square. Bracket closed. Which is equal to 0. Is that clear? So this is the expansion of this determinant. Which is equal to 0. Right? So let's take out common here. So minus is common here. P alpha square plus 2Q alpha plus R into, again here also you can take minus common. So minus within bracket. This is Q square minus PR is equal to 0. So minus into minus is plus. Now you can multiply these two. Minus into minus plus. So let us write down this first. Q square minus PR into P alpha square plus 2Q alpha plus R bracket close is equal to 0. So now what was given in the question? It was given that PQR are not in geometric progression. And there we derived some condition out there and we had marked it as 1. That was, you can check your copy, that was Q square minus PR not equal to 0. So what does it indicate? What does this equation indicate? Either q square minus pr is equal to 0 or p alpha square plus 2q alpha plus r is equal to 0. Okay? Either q square minus pr is equal to 0 or p alpha square plus 2q alpha plus r is equal to 0. But from the given condition we can write down that but q square minus pr not equal to 0. That means which is equal to 0? This one is equal to 0. That is, therefore p alpha square plus 2q alpha plus r is equal to 0. So this is the result to be proved. So we have proved it. So this is the answer. So this is also important question. So you can copy it. So we'll do the next question from higher secondary question papers, right? So you can copy it. Now we will do the next question, that is from higher secondary 2018. Okay, so you are asked to prove that this third order determinant is equal to AB plus BC plus CA whole cube is there. Okay, so what is the determinant given here? In the first row, first element minus BC, second element B square plus BC, third element C square plus BC, right? What is the second row? What is the first element? A square plus AC, second element minus AC, third element C square plus AC, right? And what is the third row here? What is the first element? A square plus AB, second element B square plus AB, and what is the third element? This is minus AB, okay? So you have to prove is equal to AB plus BC plus CA whole cube, right? So let us prove it. So let us write down this left hand side again. But you have to write down this D is equal to, write down this one again. So D is equal to this third order determinant. So how will you simplify it now? So in this case, you cannot use properties directly here. Okay. So what we will do here is that in the first row, A is missing there, isn't it? Among these A, B and C, A is missing in the first row, right? In the second row, which is missing? B is missing. In the third row, C is missing, right? So in the first row, you have to multiply it by A, second row multiplied by B, third row multiplied by C. But you have to cancel it because we are multiplying ourselves. So you have to cancel that. So you should write before determinant 1 upon A, B, C. In order to cancel A, you have to write 1 by A. In order to cancel B, you have to write 1 by B. In order to cancel C, you have to write 1 by C, isn't it? So let us write down is equal to, this is equal to 1 upon ABC. 1 upon ABC. Now let us multiply all the elements of the first row by A. So it is minus ABC, right? It is multiplied by A, AB square plus ABC. It is also multiplied by A, AC square plus ABC. Is that clear to all of you? Now multiply by B in the second row. So it is A square B plus ABC. This is minus ABC. This is BC square plus ABC. Is that right? So next, multiply third row by C. What do we get? A square C plus ABC. Next, this one, B square C plus ABC. Next, this is also minus ABC. Is it clear now? So now, what will you do in the next step? Again, you have to take common A from the first column, B from the second column, and C from the third column. Okay? Let us take here A common, here also A common first. From here you should take B common. From these two you should take C as common. Okay? So from this each and every element you take common here. Okay? So is equal to 1 upon ABC. Now in the first column minus ABC. Write it, keep it same. Here A is common. If A is taken common here within bracket, what do we get? AB plus BC. Is that clear? Here also you take A common. If A is taken common within bracket, what do we get? AC plus BC, right? So AC plus BC, okay? Now from the second column, you have to take B common. First of all, you take B common from this term. So B is taken common. So within bracket, what do we get? AB plus AC. It is AB plus AC. From next, minus ABC. Minus ABC. From next third term, what is common here? Also B. So B is taken common within bracket. What do we get? BC plus AC. It is BC plus AC. So I think it's correct. You can check it also. Okay. So next, third column. From the third column, in the first term, you take C as common, right? So C is taken common within bracket. What do we get? Tell me. It is AC plus AB. It is AC plus AB. Is that clear? I think you have understood it. Next, here also C is taken common. If you take C as common, what do we get within bracket? It is BC plus AB, right? And then the third element remains same, that is minus ABC. So determinant sign is closed here. Is it understood now? So you can copy it. So next, what will you do in the next step? From the first column you take A common. From the second column you take B common. From the third column you can take C common. That is ABC is taken outside determinant, which is equal to ABC divided by ABC, right? So write on the first column minus BC, AB plus BC, then AC plus BC. Is that correct? Okay. Next, from the second column, B is taken common. AB plus AC, B is taken common minus AC, B is taken common, BC plus AC. Is that right? Next, what is the third column here? C is taken common from the third column, isn't it? So it is AC plus AB. It is AC plus AB. Next, BC plus AB. Next, C is taken common here, so it is minus AB. So here determinant sign is closed. And you can cancel this ABC by ABC, that is 1. It is divided, that is 1. Okay? So now what will you do next? So now look at the blackboard. So if you use the property, but you have to consider the right hand side also. What is to be proved on the right hand side? What is the question? It was you have to prove AB plus BC plus CA whole cube, isn't it? So one of the factors that you should get here is AB plus BC plus CA. So how can you get it? Let us check it. C1 plus C2 plus C3. If you do C1 dash is equal to C1 plus C2 plus C3, let's see what happens here. This plus this plus this. Minus BC plus AB. So no, you cannot do it. AB plus BC plus CA. You won't get here AB plus BC plus CA, isn't it? Right? Let's do it from R1 plus R2 plus R3. Minus BC plus AB plus BC plus AC plus BC. BC can cancel. You will get AB plus BC plus AC. Yes, you are getting it. Next, again, if you add all these terms in the second column, what happens? AC cancels. AB plus BC plus AC. Yes, we are getting it. Again, check. What do we get if you add all the terms in the third column? Minus AB plus AB gets cancels. You get AB plus BC plus AC. So we are getting the same element in the first row. If you do R1 dash is equal to R1 plus R2 plus R3. But we are not getting in case of C1 dash is equal to C1 plus C2 plus C3. Is that clear now? So which property is used here? Which property is used here now? So R1 dash is equal to R1 plus R2 plus R3. Now let's use this property. That is R1 dash is equal to R1 plus R2 plus R3, right? So now, therefore, this is D is equal to, isn't it? So D is equal to, what is the first row now? Minus BC plus BC gets cancelled, we get AB plus BC plus AC. AB plus BC plus CA. Okay? Now again add all those terms in the second column. AC gets cancelled, we get AB plus BC plus CA. Same element is there. AB plus BC plus CA. Is that right? Next, what is the third row? What will be the third row now? What is the third row? Again, all the elements, add all those elements in the third column. That is not third row, that is third column, right? Minus AB plus AB gets cancelled, AB plus BC plus AC. This is AB plus BC plus CA. Is that clear to all of you? So this is R1 dash is equal to R1 plus R2 plus R3. Now in this case, second row and the third row remain same. So let us write AB plus BC minus AC, BC plus AB. Next, AC plus BC. Next, BC plus AC, BC plus AC, then minus AB. Is that right? So now what will you do in the next step? You can take common. What is that common from the first row? You can take it outside determinant, you know that. Now what is common out here, isn't it? So D is equal to AB plus BC plus CA. So what is the first row? 1, 1, 1. What is the second row? Remain same, AB plus BC minus AC, BC plus AB. Right? Now AC plus BC, AC plus BC, BC plus AC, AC plus BC, BC plus AC, then minus AB. So here determinant sign is closed. Is that clear now? So what is the advantage if there are 3 ones in one row? You can make any 2 of these ones 0 by using properties so that you can easily expand it. Okay? So let us make 2 of these ones 0. Okay? So what is the property that you can use here? So I already told you that in a third order determinant, at a time maximum 2 properties can be used to make 2 ones 0 out here. Okay? So now let's use this property. C1 dash is equal to C1 minus C2. You may do C2 dash is equal to C2 minus C1, right? And let's do C2 dash is equal to C2 minus C3. You may do C3 dash is equal to C3 minus C2 or C3 minus C1. Okay? But you have to use maximum 2 properties at a time in case of third order determinant, but not more than 2 properties can be used in case of third order determinant. Okay? So let's use this property now. Therefore D is equal to, within bracket, AB plus BC plus CA, right? Next, now C1 minus C2, C1 dash, column 1 is changing. How does it change? C1 minus C2, 1 minus 1, this is your 0, this minus this now. AB plus BC plus AC, that is minus and minus plus AC. And again, C1 minus C2, this minus this, AC minus AC, cancel it, BC minus BC, cancel it, that means it is 0. Is that clear? Next, what is the property that we can use here? C2 dash is equal to C2 minus C3. Now column 2 is changing. So 1 minus 1 is, here also it is 0. This minus this, what do we write? Minus AC minus BC, let us write here minus AB, right? किनभने अटेन त्यही कारणले गर्दा हामीले यो सेकेन्ड एलिमेन्ट द सेकेन्ड कलम चाहिँ यसरी लेखेको minus AC minus BC minus AB, right? Next one is, what is C2 minus C3? BC plus AC minus U minus plus AB, that is AB plus BC plus AC. Now Now this third column remains same. So right now it is 1. What is it? Let us write this element as BC plus AB. यहाँ पनि अटेन, त्यही कारण हामीले यो सेकेन्ड एलिमेन्ट अफ द थर्ड कलम चाहिँ हामी BC plus AB चाहिँ अलि तल लेख्यौं ल, किनभने त्यहाँ अटेन BC plus AB. Then write down minus AB. This is your minus AB. So this determinant is closed. Is it clear? So now this third column is, first element is 1. What is the second element? Third column ma first element 1 cha, second element BC plus AB, and third element cha minus AB. Is that right? Okay. Now let's simplify it now. So again we'll write down here, right? So therefore D is equal to AB plus BC plus CA, right? What is the first column? 0. AB plus BC plus AC. This is also 0, right? Next, 0. This is minus AC minus BC minus AB. This one is AB plus BC plus AC. Then what is the third column? 1. This is BC plus AB. And then this is minus AB. Now you can copy it. Okay. Same determinant is written out here. किनभने यहाँ हाम्रो मिलेन यो, मतलब अटेन यो, बुझ्नुभयो नि? नर्दा चाहिँ अलि कसो कसो लेख्यो, त्यही कारण यहाँ लेखेको ल यो. Now you can copy it. You can copy it. So next, what will you do? You can expand it. You can expand it with respect to the first row because there are two elements 0 in this case. Now let us expand it with respect to the first row. So D is equal to AB plus BC plus CA into, now expand it with respect to the first row. What is the method? Plus minus plus. But 0 comes first, plus 0. But will you write 0? No, because 0 into any number is always 0. Minus 0. 0 into any number is always 0. Plus 1. You should write 1 here. Now within second bracket. Now if you consider this 1, you have to delete the row and the column through the element 1. That means first row and third column are deleted. What remains? What remains? AB plus BC plus AC. Minus AC minus BC minus AB, 0, and AB plus BC plus AC. This is the second order determinant. You know how to expand this second order determinant, isn't it? First of all, you have to cross multiply AB plus BC plus AC by AB plus BC plus AC. That means, how much is it? These are same expressions. AC whole square. Then, बीच के साइन आयो minus. Now cross multiply 0 by this expression. Minus AC minus BC minus AB. That is 0. Second bracket is closed. Is it clear? Now this is the expansion of this determinant. You know how to expand it, isn't it? So now, therefore, what is D is equal to? Now you have to multiply these two factors. 0, you don't have to write it. So if you multiply these two factors, powers will be added. That is AB plus BC plus CA whole cube. Is that clear? So is it proved? You can check the answer. So the correct answer is AB plus BC plus CA whole cube. So the answer is given in the question itself. That is, you have to prove that. Okay. So we got the correct result here. So the answer is left hand side is equal to right hand side. That is AB plus BC plus CA whole cube. So I think you have understood it. You can practice it at home. So we'll do the next question. Okay. Now we are doing the next question, that is from Higher Secondary 2019. The problem number is 2B number 2. You have to show that. You have also prove that this determinant is equal to this expression. That is, here also third order determinant is given. What is the first row? First element 1 plus A, 1, 1. Second row 1, 1 plus B, 1. What is the third row? What is the first element? 1, second element 1, and third element is 1 plus C. Is equal to, you have to prove that expression ABC within bracket 1 plus 1 upon A plus 1 upon B plus 1 upon C. So let us write down the left hand side determinant. Okay, that is, let D is equal to, so let us copy this one, 1 plus A 1 1 1 1 plus B 1 1 1 1 plus C. Okay, so now you have to consider the right hand side also. The right hand side हेरेर मात्रै हामी यो डिटर्मिनेन्टमा के गर्नुपर्ने हो थाहा पाउँछौं. ठीक छ. So here it is 1 upon A, 1 upon B, 1 upon C is there, but there is no 1 upon A, 1 upon B, 1 upon C, right? So let's do one thing. Let us write here, instead of 1, can you write A by A? Yes, we can write it. 1 also A by A. If you multiply 1 by A by A, if you write A by A gets cancelled, you get 1. Here also A by A gets cancelled, you get 1. But we are multiplying ourselves by A by A here. You have to multiply the first element by A also. Similarly, in the second element, instead of 1, write B by B, this is also B by B, this is also B by B into 1 plus B, right? And what will you do in the third row now? C by C, C by C, C by C into 1 plus C. Is that clear? The C by C means 1, A by A means 1, B by B means also 1. Okay? So let us simplify it like this. So D is equal to, now first row, A by A within bracket 1 plus A. You can do it column wise also. हामीले कलममा पनि त्यस्तो गर्न सक्छ, A by A by A by A. सेकेन्ड कलममा B by B, B by B, B by B. थर्ड कलममा C by C, C by C, C by C. तर हामीले यो रो वाइज गर्दैछौँ र जुन चाहिँमा गर्दा पनि हुन्छ. त तिमीले घरमा गर्दा कलम वाइजमा गरी हेर्नु, तिमीले आन्सर निकाल्न सक्छौ. बुझ्दैछ? So instead of this one, what will you write? A by A. Instead of 1, this also, what will you write? This is A by A, right? Now second row, this is 1 means B by B, this means B by B within bracket 1 plus B, and this one means B by B, B by B, right? Next one is C by C, this is also C by C, this one is C by C within bracket 1 plus C. So we got this expression. Okay? So now you have to prove this result. Okay? Let us write it here. ABC within bracket 1 plus 1 upon A plus 1 upon B plus 1 upon C. We will prove this result. Now next step, what will you do? A by A ले 1 plus A लाई multiply गर्नु, 1 plus B is multiplied by B by B, there is also 1 plus C is multiplied by C by C. Okay? So therefore D is equal to, what do we get here? A by A. A by A into 1 plus A. So don't multiply them. Let us take common out here. Let us take common out here. Okay? Since ABC is common here, you have to prove ABC as common, isn't it? Let us take A common from the first row. Let us take B common from the second row. Let us take C common from the third row. Okay? So what do we get here? It is ABC. Now what is the first row? 1 upon A, 1 plus A, then 1 upon A. This is also 1 upon A, right? From the second row, B is common. 1 upon B, this is also 1 upon B within bracket 1 plus B, this is also 1 by B. What is the third row? 1 upon C, C is taken common here, 1 upon C, this is also 1 upon C within bracket 1 plus C. So we got this determinant, so you can copy it. So now what will you do in the next step? Now you can multiply them. 1 upon A should be multiplied by 1 plus A. 1 plus B should be multiplied by 1 by B. 1 plus C should be multiplied by 1 by C. Let's multiply. So therefore D is equal to ABC. So what do we get? 1 upon A plus 1 upon A into A is 1. 1 upon A, 1 upon A, right? Next, this is 1 upon B multiplied by 1 upon B here. 1 plus, this is 1 by B into 1, 1 by B plus 1, this is also 1 by B, right? And this one 1 by C, this one 1 by C, this one 1 by C plus 1. So here determinant sign is closed, right? So now what will you do? So what can you do here? So now you should get on the right hand side one of the factors. There is 1 plus 1 upon A plus 1 upon B plus 1 upon C. So how can you get this factor now? So if you do R1 plus R2 plus R3, that is 1 plus 1 upon A plus 1 upon B plus 1 upon C. This one is also 1 plus 1 upon A plus 1 upon B plus 1 upon C. This one is also 1 plus 1 upon A plus 1 upon B plus 1 upon C. Is that clear? So let's do here. R1 dash is equal to R1 plus R2 plus R3, right? So what is D now? D is equal to, it is ABC. What is the new first row? You can add all those elements in the first column. It is 1 plus 1 upon A plus 1 upon B plus 1 upon C. This is 1, right? This is here 1. Can you see it? 1 plus 1 upon A plus 1 upon B plus 1 upon C. Okay. Next, all the elements in the second column are added. That is here also 1 plus 1 upon A plus 1 upon B plus 1 upon C. Right? 1 plus 1 upon A plus 1 upon B plus 1 upon C. Here also what do we write? 1 plus 1 upon A plus 1 upon B plus 1 upon C. All the terms in the third column are also added. So we got the new first row. That is R1 plus R2 plus R3. Now second row and third row remain same. This is 1 upon B plus 1. This one is 1 upon B. What is the third row? It is 1 upon C. This is also 1 upon C. This is also 1 upon C plus 1. So here determinant sign is closed. Is that clear now? So what will you do in the next step? So there is common here. You can take it outside. You can take it common outside. So take common. What is common here? 1 plus 1 upon A plus 1 upon B plus 1 upon C. So therefore D is equal to ABC within bracket 1 plus 1 upon A plus 1 upon B plus 1 upon C is taken common. What is the new first row now? It is 1, 1, 1. Second row remains same, 1 upon B plus 1. This is 1 upon B, right? Next, so 1 upon C, this is 1 upon C plus 1. So this is the determinant, okay? So there are 3 ones in the first row. You can make any 2 of these ones 0 by using the properties here. So what type of property will you use here? This is property number 5. What is that property number 5? How can you use it? C2 dash is equal to C2 minus C1 and C2 dash is equal to C2 minus C1 and C3 dash is equal to, what will you do? Will you do C3 minus C2 or C3 minus C1? Which one is easier? You may do C3 minus C2 also or C3 minus C1, but which one is easier? C3 minus C1. C3 dash is equal to C3 minus C1. So let's use this property now. So therefore D is equal to ABC within bracket 1 plus 1 upon A plus 1 upon B plus 1 upon C, right? So now what is the first column? First column remains same. 1, 1 upon B, 1 upon C. What is C2 dash? New column 2, C2 minus C1, 1 minus 1, 0. This minus this, 1 upon B will be cancelled, you will get 1. 1 by C minus 1 by C, that is 1. Okay? Again, what is C3 minus C1? That is column 3 is changing. So 1 minus 1, 0. 1 upon B minus 1 upon B, 0. C2 minus C1, isn't it? So this term is 1 upon C. minus 1 upon c, this one is 0. Sorry, मैले यहाँ अलिकति मिस्टेक गरेछु. c2 minus c1 गर्दै थिएँ नि हैन. 1 minus 1 is 0. 1 upon b plus 1 minus 1 upon b is 1. 1 upon c minus 1 upon c is 0. Right? Similarly, third column, c3 minus c1, third column is changing. 1 minus 1, 0. 1 upon b minus 1 upon b, 0. 1 upon c plus 1 minus 1 upon c, that is 1. Is that clear now? So this is the simplified determinant. Now you can expand it because there are two elements 0 in the first row. Let us expand it. So d is equal to abc within bracket 1 plus 1 upon a plus 1 upon b plus 1 upon c into, let us expand it with respect to the first row. In the first row there are three elements 1, 0, 0. So what is the method? Plus minus plus. So plus 1, write on plus 1 within bracket. You have to forget about the row and the column through the element 1. That means you forget about the first row and the first column. So what remains? 1, 0, 0, 1. This is the second order determinant. You know how to expand it. So you have to cross multiply 1 by 1. That is 1 minus 0 into 0 is 0. Now then comes minus 0. But will you write 0? No, because 0 into any number is always 0. Then comes plus 0. Here also 0 into any number is always 0. So don't write 0. So this is the expansion. So you can multiply. So this is your 1. 1 into your organic number ke bhayo? A, B, C into 1 plus 1 upon A plus 1 upon B plus 1 upon C. Proved. So we have proved the required result. Here prove गर्नुपर्ने थियो नि, त्यहाँ अगाडि हामीले लेखिसकेका थियौं. That is, we have to prove ABC into within bracket 1 plus 1 upon A plus 1 upon B plus 1 upon C. So we have proved it. Is it understood now? So you can copy it. Now we'll do the next question from XS question papers, right? So now we will do this question from higher secondary question paper, that is HS 2017. You have to prove that this determinant is equal to minus a cube plus b cube whole square, right? So what is the third order determinant given here? In the first row, first element 2ab, a square, b square. Second row, in the first element a square, second element b square, third element twice ab. And in the third row, first element b square, second element 2ab, and the third element is a square. You have to prove that, you have to prove this determinant is equal to right hand side. What is right hand side here? Minus within bracket a cube plus b cube whole square. You have to prove this result, that is minus a cube plus b cube whole square, right? So let's prove this right hand side, which is minus within bracket a cube plus b cube whole square. So let us write down this left hand side again. Write it once again, that is d is equal to this left hand side determinant. Okay, so now what will you do here? Let us check it. If you do r1 plus r2 plus r3, it will be 2ab plus a square plus b square. That is the formula a plus b whole square, isn't it? Here also a square plus b square plus twice ab, a plus b whole square. Here also a square plus b square plus twice ab, this is also a plus b whole square. That is, we are getting the same elements in the first row. So you can do column wise also. If you do c1 plus c2 plus c3, what is new column 1? It will be 2ab plus a square plus b square, that is a square plus 2ab plus b square, you will get a plus b whole square. Here also, if you add all these three terms, what do we get? A square plus 2ab plus b square, there is also a plus b whole square. And if all the elements of the third row are added, what do we get? A square plus 2ab plus b square, there is also a plus b whole square. That means we are getting the same elements a plus b whole square in the first column. you can take that common outside determinant. Okay, so you can use the properties here column wise or row wise, right? So let's do column wise here. That is C1 dash is equal to C1 plus C2 plus C3, right? So therefore D is equal to, what is the new first column here? A square plus 2AB plus B square, right? Next one is also add all those three terms in the second row, A square plus 2AB plus B square. This one is also A square plus 2AB plus B square. What is the second column now? A square, B square, 2AB remains same. Third column also remains same, B square, 2AB, and this is A square, right? So second column and third column remain same. So what is common here? A square plus 2AB plus B square is common. You know that it is A plus B whole square, isn't it? So therefore D is equal to A plus B whole square is taken common here from the first column. Now what is the first column now? It is 1, 1, 1, right? What is the second column? A square, B square, then what? 2AB. Then what is the third column? B square, then 2AB, 2AB, then what is here? It is A square. Is that clear now? Now we see here that there are three elements same, that is 1, 1, 1 in the first column. So you can make any two of these ones 0. Okay, so how can you make it? You can write R2 dash is equal to R2 minus R1, or you may write R1 dash is equal to R1 minus R2 also, or R2 dash is equal to R2 minus R1, and which property here? R3 dash is equal to R3 minus R2. You may write R3 dash is equal to R3 minus R1 also. Okay, so let's do R3 dash is equal to R3 minus R2. Is that clear? Is that clear to all of you? Or you may do R3 minus R1 also. Let's do R3 minus R1. Let's do R3 minus R1, right? So it is R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R1, right? So therefore D is equal to A plus B whole square. Now in this case, which row remains same? That is first row. First row remains same. That is 1A square B square. Now second row is changing. How does it change? R2 dash is equal to R2 minus R1. 1 minus 1, 0. This is B square minus A square. Right? Next 2AB. This is 2AB minus B square. Is that clear now? Next, what is R3 dash? R3 minus R1. This is 1 minus 1 is 0. Next, 2AB. This is 2AB minus A square. Right? Next one is A square minus B square. It is A square minus B square. So here determinant sign is closed. So I think it's clear. So I think you have understood it. Okay. Now you can expand it. You can expand it with respect to which row or which column? From the first column. So with respect to the first column, you can expand this determinant, isn't it? So let us expand it. So therefore, D is equal to A plus B whole square. Now you can expand it with respect to the first column. That is 1, 0, 0. So what is the method now? You have to consider the sign also. Plus 1 minus 0 plus 0. So first of all, it is 1. So within second bracket. Now this one is considered. You have to delete the row and the column through the element 1. That means first row and first column are deleted. What remains? B square minus A square, 2AB minus B square, 2AB minus A square minus B square. So this is your second order determinant. You know how to expand it, isn't it? So we can do cross multiplication. Cross multiply B square minus A square by A square minus B square. What do we get? B square minus A square into a square minus b square, right? Next sign is minus sign. Minus sign, again you have to cross multiply 2ab minus b square by 2ab minus a square. That is minus 2ab minus b square into 2ab minus a square. Yes, second, this is the this is your first term actually. So second bracket is closed. Okay, let us write it as third bracket because we are expanding this determinant. Okay, so this first term is completed. Next, minus 0 is there, but will you write 0? No, 0 into integral number is always 0. Plus 0, will you write plus 0? No, 0 into integral number is always 0. So this is the only expansion of this determinant, right? So let us simplify it. Therefore d is equal to, this is your a plus b whole square. So now within second bracket, now a square minus b square, you can write here a square minus b square, isn't it? Minus within bracket a square minus b square. Let us make it a square minus b square. So this is also a square minus b square. Is that clear? Now let us simplify the next two factors. Minus 2ab into 2ab, this is 4a square b square. Is that clear? Then minus to minus, plus this is 2a cube b, 2a cube b, minus to minus, plus how much is it? 2ab cube, 2ab cube, right? Then comes minus to minus, plus to minus, minus a square b square. This is your a square b square. Second bracket is closed. So now let us check it once again. Here minus is taken common, a square minus b square. It remains same, minus. Now we have multiplied. This is 2ab into 2ab, 4a square b square. Minus to minus, plus 2a cube b, minus to minus, plus 2ab cube. Minus to minus, plus to minus, minus a square b square. Is that correct? Now it's correct. Okay? So let's simplify it now. Therefore d is equal to, this is your a plus b whole square within second bracket. What is here? Minus a square minus b square whole square, right? Then write down this one, minus 4a square b square, right? Then comes plus. What is common from these two terms? What is common here? That is 2ab, right? 2ab is common within bracket. It is a square plus b square, right? Here 2ab is taken common, so it is a square plus b square. Then last one is minus a square b square. Second bracket is closed. Is it clear now? Now next, what is common here? From these two you can take common, minus is taken common, or d is equal to, now it is a plus b whole square within second bracket. What is common here? Only minus is taken common. Let us write it as third bracket. Minus within second bracket. What is here? From these two only minus is taken common. So it is a square minus b square whole square, minus to minus, plus 4a square b square. Second bracket is closed. Clear? Then plus 2ab into a square plus b square, right? Then what is the last one? You can write it as ab whole square. Second bracket is closed. Is that clear? So next one is, now d is equal to a plus b whole square. Now within third bracket, minus. Now can you tell me what is the formula for this one? This formula is used here. A minus b whole square plus 4ab. A minus b whole square plus 4ab is there, isn't it? Instead of a, there is a square. Instead of b, there is b square. So what is the formula in this case? What is the formula? What is a minus b whole square plus 4ab? It is a plus b whole square. this is your a plus b whole square. That is a minus b whole square plus 4ab is equal to a plus b whole square. That is another formula for a plus b whole square, right? So instead of this, what will you write now? It will be like this formula. You can write a square plus b square whole square. Okay, then write on this one plus twice ab into a square plus b square. So we know this formula, right? Then minus, it is ab whole square, third bracket is closed. Is that clear? Now what is common here now? You can take minus common outside, or d is equal to minus a plus b whole square, right? Is that right? So you can take minus common here. So you take minus common. So minus is taken outside, a plus b whole square. So within third bracket or within second bracket, what do we get? It is a square plus b square whole square. Minus into plus, minus twice. Let us write down this one. A square plus b square first, because this is the term of a. This is also the term of a. Then what do we write? This is the term of b. B twice ab. Then minus into minus plus, this is ab whole square. Is that clear? Now in this case you can use the formula. If you write a instead of a square plus b square, and if you write b instead of ab, what is the formula here? A square minus 2ab plus b square. The key formula here is a minus b whole square, right? So or d is equal to minus a plus b whole square. What is this formula? It is a plus b whole square, isn't it? Here a is a square plus b square, and what is b? ab, right? So what is a minus b whole square in this case? A is a square plus b square, then comes minus, what is the value for b here? It is ab whole square. Is it understood now? So both are whole square. You can write it in terms of whole square. Like if you have a square b square, so what will you write for this one? If it is a square b square, what will you write? This is ab whole square. But likewise, similarly, you can write here. That is, you can put it within whole square. Or d is equal to minus, within second bracket, a plus b into a square. You can write minus ab first, then plus b square, second bracket closed, whole square. Okay? So I think you know this formula. A plus b into a square minus ab plus b square. So what is the formula for this one? There is a formula, isn't it? That is a cube plus b cube is equal to, what is the formula? A plus b into a square minus ab plus b square. So same formula is there, isn't it? So what can you write instead of these factors? What can you write instead of this factor? A cube plus b cube. Or d is equal to minus, within bracket, a cube plus b cube. This is whole square. So it is proved. So you can take the answer. You have to prove that left hand side determinant is equal to minus, within bracket, a cube plus b cube whole square. So in this way you can prove it. Now let's do another problem. So now we will do this question. This is from the sent-up question paper, that is Inter-School Higher Secondary Test Examination. Okay, so this question is from sent-up examination, that is sent-up examination 2016. So in the question it is asked that without expanding you have to prove that this determinant is equal to 0. It is given out here, right? So it is, what is the first row? 1 AB 1 upon A plus 1 upon B. What is the second row? 1 BC 1 upon B plus 1 upon C. What is the third row? 1 CA 1 upon C plus 1 upon A is equal to 0. You have to prove this result. That is left hand side is equal to 0. So let us write down this left hand side. That is, let us write D is equal to this determinant. Okay. So here also you cannot expand it. That means you have to use some properties of determinant out here. Okay. So this carries 2 marks. But you cannot expand it. You have to prove this determinant is equal to 0. As now here, you can take the LCM, isn't it? Let us simplify. The third column, D is equal to 1, 1, 1. Here, you 1, 1, 1 देख्ने बित्तिकै दुईटा एलिमेन्टलाई 0 बनाउने हैन है. किनभने दुईटा एलिमेन्टलाई 0 बनाएपछि तिमीले एक्सपेन्सन गर्नै पर्छ. But you cannot expand here. Is that clear? So this is 1, 1, 1. A, B, B, C, C, A. त यहाँ दुईटा एलिमेन्टलाई 0 बनाउनु सक्दैन यहाँ. किनभने you have to expand it. Then only it will be 0. Okay, but you cannot expand here, right? So what's the LCM? AB, so it is B plus A. Here also what's the LCM? BC, it is C plus B. You know how to simplify it. This is CA. What's the CA is the LCM? What's the element in the numerator? That is A plus C. A plus C. Okay. Now let us cancel this AB, BC, CA in the denominator. So in the first term, in the first column, there is AB in the denominator, there is BC in the denominator, there is C in the denominator. You have to cancel it. Okay. But if you multiply by ABC, ABC and ABC, this AB will be cancelled, BC will be cancelled, CA will be cancelled. Okay. So this each and every term should be multiplied by ABC. So we are multiplying ourselves. That is to be cancelled. So outside determinant you will write 1 upon ABC. So therefore D is equal to, this is 1 upon ABC, right? First column remains same, 1, 1, 1. Third column remains same, first column remains same, second column remains same, that is AB, BC, and this is CA. Is that clear? But in the third column, each and every element should be multiplied by ABC. So what do we get? ABC within bracket this term, write down this term, B plus A by AB, right? Next, this second term is also multiplied by ABC. So within bracket, C plus B divided by BC. Again, this third element of the third column is also multiplied by ABC. So ABC within bracket, what do we get? A plus C divided by CA. Is it clear now? Since we have multiplied each and every element of the third column by ABC, so you have to cancel it, isn't it? So in order to cancel it, we have written 1 upon ABC here outside determinant. Is it clear now? So here you can cancel, this AB gets cancels, here this BC gets cancelled, here this CA gets cancels. So therefore D is equal to, this is 1 upon ABC. Now first column remains same, that is 1, 1, 1. What is the second column? AB, BC, CA. This is the second column. Is that clear? Now what is the third column here? Write down. What is the third column? Now what is the third column? In the third column, in this third column you can simplify the term. You can multiply B plus A by C, that is BC plus CA. What is the second element? Multiply by A here, CA plus AB. Next, multiply by B here, AB plus BC. So we got this new elements in the third column. Now what will you do in the next step? So you can use the property here. If you do C3 plus C1, this is CA plus BC plus AB, AB plus BC plus CA, this is AB plus BC plus CA. That means we are getting the same elements in the third column. If you apply the property, C3 dash is equal to C3 plus C2. Is it clear? Now let's use this property. Now C3 dash is equal to C3 plus C2. That means column 3 is changing. How does it change? C3 plus C2. So therefore D is equal to 1 upon ABC. Now first column remains same, 1 1 1. Second column AB, BC, CA. Now third column. What is third column now? How does it change? It is C3 plus C2. That means this plus this, AB plus BC plus CA. Similarly, this plus this, C3 plus C2, CA plus AB plus BC, AB plus BC plus CA. Again, C3 plus C2, AB plus BC plus CA. That is AB plus BC plus CA. Is that clear? Now you can take common. So you can take common from the third column. What is common out there? AB plus BC plus CA. That is D is equal to AB plus BC plus CA is taken common. This whole divided by upon ABC. What is the first column here? 1 1 1. Second column AB, BC, CA. And what is the third column now? It is 1 1 1, because in this case AB plus BC plus CA is taken common outside. Okay. So now therefore D is equal to AB plus BC plus CA, AB plus BC plus CA whole divided by ABC into. So what is the value of this determinant? I told you that in property number 3, if two rows or two columns of a given determinant are identical, then the value of the determinant is always 0. So in this case, this first column and third column are identical. So what is the value of the determinant? It is 0 into 0. That means D is equal to 0 into any number is always 0. Proved. So which is equal to right hand side. So we have proved it. So this is very important question. Okay. So this question is from CENTUP 2016. Okay. So you can copy it. We'll do the next question now. So now we will do this question from higher secondary question paper HS 2016. That is, this question is from number 1B. That is from part A. This question carries 2 marks only. Okay. So here it is given that this second order determinant is equal to this second order determinant. What is the second order determinant here? First row is 2 and 3. Second row 4 and 5. This is also the second order determinant. First row x and 3, second row 2x and 5. You have to find out the value of x. So let us write down given part here. So which is the given part here? So here given is 2, 3, 4, 5 is equal to x3, 2x, 5. Right? So in this case you can expand it. This is the case of determinant, isn't it? So you can expand the second order determinant. You know how to expand it. Now, you know how to expand the second order determinant, isn't it? Now, in the first column, you have to take the first element. Which is the first element? 2. This 2 is cross multiplied by 5. 2 5s are 10. Always, you have to multiply first. That is, which is the first element in the first column? That is 2. This should be cross multiplied by 5. But not 4 by 3 first. Okay? So, first of all, you have to cross multiply 2 by 5. 5 2s are, it is 10. जहिले पनि पहिला यो फर्स्ट कलम को फर्स्ट एलिमेन्ट ले सेकेन्ड कलम को सेकेन्ड एलिमेन्ट मल्टिप्लाई गर्नु पहिला चाहिँ. So 2 5s are 10. This is the rule. Okay. Minus. Then comes what? This 3 is cross multiplied by 4. That is 4 3s are 12. Is that clear? Now first of all you have to multiply 2 by 5. This is the rule. 2 5s are 10. With a minus sign. 4 3s are 12. Is equal to here also the same case. This first element of the first column should be multiplied by second element of the second column. That is cross multiply x by 5 first. But you cannot multiply 2x by 3 first here. Isn't it? You have to multiply x by 5. This is the rule. So x into 5 is 5x, right, minus 3 into 2x, that is minus 6x. Is that clear? And now this is what is 10 minus 12 minus 2 is equal to 5x minus 6x. What is it? Minus x. From both the sides you can cancel this minus you can cancel them. So 2 is equal to x. Therefore it is x is equal to 2. Is that clear? So this is the second order determinant. The how will you solve it? You have to solve it. That means you have to get the value for x. It is just like solving, isn't it? So first of all, you have to expand this second order determinant. That is 2 5s are 10 minus 4 3s are 12 is equal to x into 5, 5x. Then it is minus 6x. Okay. 10 minus 12 minus 2 is equal to, this is minus x, minus gets cancelled. So 2 is equal to x. That means x is equal to 2. So this is the answer. So what is the value of x here? That is x is equal to 2. Is that clear to all of you? So you can revise all the problems that we have done today. So तिमीले घरमा यो राम्रोसँग प्रब्लम प्र्याक्टिस गर्ने, किनभने यो सबै एचएस क्वेशन पेपरबाट मात्र मैले आज गरे। त्यसलाई घरमा राम्रोसँग रिभिजन गर्नु, ठीक छ? त नेक्स्ट क्लासमा चाहिँ म तिमीलाई अब नेक्स्ट क्लास चाहिँ हामी इन्भर्स सर्कुलर फंक्शन्स गर्छौं। अब बुझ्नु छैन? त डिटर्मिनेन्ट यो जुन चाहिँ च्याप्टर छ, यो डिटर्मिनेन्ट को च्याप्टर प्राय नै कम्प्लिट भयो, ठीक छ? अच्छा, नेक्स्ट डिटर्मिनेन्ट गराउँदा चाहिँ we will do how to solve three equations with three unknown quantities like x, y, z with the help of Cramer's rule. That is the application of determinant. त अब हामी डिटर्मिनेन्ट गर्दाखेरि चाहिँ हामी Cramer's rule use गर्छौं. That is how to solve three equations with three unknown quantities, that is x, y, z. Okay? The next class मा चाहिँ हामी के गर्छौं? Inverse circular function गर्छौं, ठीक छ? So this much is for today. So have a good day and take care of yourself. Stay at home and stay safe.